All right. How you doing? Everything all right? Ready for a final session before the final keynote? Excellent. So, do you know what this is? This is the amazing fish cam. And in fact, this is the second webcam that was ever publicly available over the internet. The year is 1994. We're at Netscape Communications headquarters, where the fish tank is and the camera. And for those of you, well, how can I put this? Young enough to not know what a Netscape is. You might want to ask someone with a little less hair, going grayish like myself, and they will probably tell you that Netscape, they created this awful, horrible piece of amazing magic software that opened up the web for us and kind of kick-started this internet thing. So the computer behind the amazing fish cam was a Silicon Graphics Indie workstation. This was a fairly new kind of line of computers, and it was rather in the kind of low end of workstations. But it was still rather powerful. It came with 32 megabytes of RAM, and it could take this picture, it could overlay some graphics, and it could upload it to the internet in about 20 seconds. And you could buy it for somewhere around $5,000 US for the baseline version. So it's pretty good stuff, right? So we're going to move forward, and we're going to quickly stop at 1999. And this guy here, Kevin Ashton, he co-founded the Auto ID Center at MIT. And for the first time, somewhere around here, he mentioned this idea of Internet of Things, kind of coined the term Internet of Things. He previously come from Procter & Gamble, and his focus at this time was on RFID and RFID tagging. So he thought, well, if we could just RFID tag things around us, we'll be able to use sensors to read these tags, and they will tell us something about the world around us, about these things, where they are and what they're up to, right? And over time, we kind of expanded on this idea somewhat. Some might call it a little bit more pompous, the Internet of Everything, or the programmable world. But it's kind of about the same thing, right? It's all about connecting things to the internet and adding data from these things and combining it with other kind of data that we humans produce and upload to the internet. So we can use these things, and we can let them tell us things about the world around us. But we can also control them. And that's, we do that today. We control our TVs or Wi-Fi, hi-fi Wi-Fi systems with our smartphones. We can turn on and turn off the heating and so on. We're going to fast forward a bit, and we'll take us to 2014, which is, well, that's now. And this is 20 years after the amazing fish cam. And we could read just a few weeks ago that Google has acquired this company called Nest Labs. And Nest Labs, it was founded by Tony Fadell and Matt Rogers, credited for being kind of the brains behind the iPod line and the following iDevices at Apple. And they created Nest to take ordinary kind of boring things that we have around us and add a bit of intelligence to it. And their first product they came out with was a Nest Learning thermostat. So this is a replacement thermostat for the thermostat you have in your home, which controls your heating or cooling kind of thing. So you take out your old one and you insert this new one, which is connected to the internet using Wi-Fi, and it will start learning things about you. It will know when you're home, it will know when you're not home, when you're gone. It will know when you want it a bit warmer, and it knows when you want it a little bit cooler, right? So it will start gradually optimizing your home environment for comfort and for reducing your utility bill. So that was their first product that they launched. The second product they launched is the one that you can see here. This is I'm not sure exactly what it's named, but it's a smoke detector. And it detects smoke, right? That's what it does. So these were the two products they launched, and Google acquired them in mid-January, right, for $3.2 billion US. And that's a lot of money. In fact, that's the second biggest acquisition that Google's done after Motorola. And it's always kind of hard to tell about these things, but you might start to wonder if we're not if we're not on it, we're really close to this thing that Gartner in the infamous or famous hype cycle calls the peak of inflated expectations. I don't know, but there seems to be a huge hype about Internet of Things kind of things right now. So it's been 20 years, and perhaps it's time to stop for a while and ask ourselves, what the heck happened? What happened during these 20 years? And if we start looking, the answer turns out to be, well, quite a lot. So I'd like to select 3 things that I think have been key drivers to push us to where we are today, and talk a little bit about those. And the first thing is computing performance, here illustrated by the original graph that Gregory Moore at Intel created in the mid-60s, where he predicted that in the coming years, the density of the transistors that we can fit into an integrated circuit will double. Well, initially it said every year, later kind of changed that to every other year. And he said, well, this will go on for a few years, and then we'll see. Well, as it turned out, this went on for quite a long time. And we can argue whether or not it's still going on in one way or another. And this is really remarkable. This is really amazing when we start to think about it. So here are some of the consequences of that. We can see that integrated circuits performance doubles approximately every 18 months. You can see that disk storage capacity doubles every 14 months, and the amount of data you can push through an optical fiber doubles every 9 months, where consumer prices stays about the same. So that means that the cost for pushing data from this place to over here, over an optical fiber, halves every 9 months. And that's nothing short of spectacular. That's just amazing. That's crazy. And I don't think we don't appreciate this as much as I think we should. I think this is really cool. And this is really the foundation for everything we're going to talk about later. So what can we do with this power? Well, we could build really fast things, like the one over to the right here. Or we could build super dirt cheap things, like the Raspberry Pi. And as much as I want and I really do, really would like to have one of those Mac Pros with 12 cores and 1,000 gigabytes of RAM to do word processing on or something exciting like that. I think the real achievement is here with the Raspberry Pi. This is really awesome. I mean, this is a real computer. You can go out and buy this thing, and it will cost you about 10 cappuccinos. And for that price, you might as well you'll probably get a nice case for it, get a decent amount of storage. Right? And you have a computer that is, well, we could say about 15 times as powerful as the Silicon Graphics in the workstation we talked about. And you can have it for 1/100th of the price. And that's really cool, right? The next thing I want to talk about is a smartphone. And this one, of course, has had a huge impact on society, the way we interact, our social life and everything like that. But it also done a lot of things for pushing the technical envelope forward. Here are some of the things. It's taught us how to build really small things, but still fill them with all cool sorts of technologies. They taught us how to do radio networking, to do cell phone networking, how to do Wi-Fi networking, sort of kind of personal area networking like Bluetooth, down to near-field communication. It's all in there. We all have these in our pockets. It's taught us how to do these things while consuming a minimal amount of power. It's taught us how to build really powerful batteries that last a long time and that you can charge and discharge many cycles before they lose their stamina. And of course, another interesting thing is that it's given us a sort of a universal remote control that we all carry around us. So one interesting thing with a smartphone is the huge deployment of these things. There are literally hundreds of millions of these devices, and we're all carrying these around. And these are small, powerful computers that can do all sorts of things. It's just a platform there we can use to build cool stuff. And the third thing I want to highlight is what I call the open movement, if you wish. And this, of course, kind of started with the open source software. So you can go out and buy this very capable small computer, but you can also download a really powerful operating system for it, for free. And you get all the applications you need, you get all the developer tools you need, and it's all open source. So if you don't like it, or there's a bug, or there's something you want to fix, you can just do that. It's just right there. And we can see this paradigm moving into other areas as well. Here are a few examples from companies like Lego, Microsoft, iRobot, the Roomba, companies that might not initially be associated with openness in this way. They're starting to realize, well, not always on their own, sometimes with a little bit of help, that there's actually business sense in opening up your stuff, making it available for other people to build new things on top of this, things that they never imagined possible while they created the hardware. And we see similar things in terms of the big data and open APIs. There's huge amounts of cool things out there you can use to build new stuff. So what are people building? Well, here are 3 things that I kind of pulled off the internet. The one over here up on the left is a product called Tile. And they're leveraging or kind of betting on the idea that you can combine Bluetooth LE and Metcalfe's law to build a kind of a global lost and found kind of service. So you buy these tiles and you attach them to things you tend to lose, like your keys or your dog or your kids or whatever. And you can use them. You can use a smartphone to track them. And the cool thing about this is it doesn't have to be your smartphone that's close to this thing. It's enough that someone else is there with their smartphone as long as it has the Tile application downloaded. Now, of course, that only works if they have enough users, but given the huge deployment of these phones, well, at least they have a good start. The platform is there. The second one here is Philips Hue. It's a lighting system. It's a replacement lighting system for your home. So these are LED bulbs, which are connected. So you replace the ones you have at home and you use these instead. And if you switch them on, they will create a radio mesh network using a technology called Zigbee with each other and with a little, well, you barely see it, the little disc over here called the bridge. The bridge you connect to your Ethernet network with. So you power this thing on and you download the application. Now you can control your lights at home using your smartphone. And you can also control them if you're on the other side of the earth. Like, super useful. But the cool thing with this product is that it's built from the ground up to be hacker-friendly. So there's a web server running on the bridge that happily accepts REST calls, like JSON payloads that let you control these lights. Super simple setup. It's designed from the beginning to be hackable. You can do all sorts of cool things with this. And the last one down here is called Twine. It's like a rubber square, if you wish, that connects to your Wi-Fi network. It's battery powered and it contains a vibration sensor and a temperature sensor. So you can take this thing and you can stick it onto your washing machine, for instance. And as the cycle is done and it stops vibrating, you can have a tweet that the laundry is ready. Again, very useful. And the final one I want to show you is this one. This is the Fig alarm clock. This was a fairly successful Kickstarter project during the fall. And they were tackling the problem of getting people up in the morning by creating this nice wooden box. And it wakes you up and presents you with 3 key performance indicators of your life every morning. It lets you know how many people know you exist, how much money do you have in your bank account, and finally, how many days are left until you die? And then you said, well, okay, well, if that doesn't get you up in the morning, I don't know what will. So this, of course, is a brilliant product. But it's even more interesting if we look at the inside and we find this. Well, look at that. There's an entire computer in there. There's the Pi again. We have some breadboards and we have cabling and a few LEDs. So this is all things that you can go out and buy for very little money. So the hard problem here, except for coming up with this brilliant concept, of course, is programming, writing the software. That's the hard part. And the cool thing is that we know how to do that. Everyone in this room, I'm pretty sure, is capable of buying these parts, writing the software, and creating a product like this. And this was not the case just a few years ago. So my question to you when you leave here today is, what is your next project? In the early 90s, in the University of Cambridge, they had the computer laboratory in a rather big building. And they only had one coffee pot. And you can imagine this big building filled with computer scientists and only one coffee pot. That coffee pot was way more often empty than there was coffee in it, right? So many were those trips you took down the stairs just to find this thing empty. Very annoying. and someone realized that there was a problem here, and they put a camera in front of it, and they created this client-server kind of thing. You can see it here as the desktop client that would happily show you a 150 times 150 pixel grayscale image about the coffee pot. And you can look at this thing, and you can see, well, no need to go there today. Again, no coffee, right? Eventually, as web servers gained the ability to serve images and web browsers gained the ability to display them, this was turned into a web service. And this was, in fact, the first web camera that was ever publicly available over the internet. Now, this one had a clear purpose, right? Okay, they had this problem, and they built this thing to solve it. But I think that the only real reason you kind of need to go and build something cool is because you can. My name is Patrik Fredriksson. I work for Citerus. I want you to take all the inspiration, all the knowledge, and all the new ideas I hope you've gotten during these 3 days of J-Focus, and I want you to go home and build something cool, and then you can tweet me about it. Thank you.